With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. So in this question, what is given? There is a projectile of mass 1.2 kg undergoes a perfectly inelastic collision with the trolley of mass 3.6 kg as shown in the figure. Now in case of perfectly inelastic collision, both the objects which are colliding, they move with a constant velocity, same velocity. Now at the time of collision, the second particle is second at the time of collision, the second of the projectile is 5 meter per second at an angle of 37 degree. Basically this particle which is here, so it is striking at an angle of 37 degree and it is having a velocity of 5 meter per second. Now this 37 is with the horizontal. Now the trolley is free to move only along the horizontal rail, which coincide with the direction of the projectile horizontal motion. Now assuming that the trolley does not topple, calculate the amount of heat energy release in the collision. We need to calculate what is the amount of heat energy release in the collision. So we know that in case of perfectly inelastic collision, the kinetic energy, initial kinetic energy and final kinetic energy, basically they are not same. Okay, so there is a difference between the initial and the final kinetic energy, and this is basically the heat which is generated. So we can say that our heat would be equals to the change in kinetic energy. Now the change in kinetic energy, basically it would be initial kinetic energy minus final kinetic energy. Why? Because in case of perfectly inelastic collision, initial kinetic energy is always more, so there is a loss of kinetic energy. Okay, now just we need to calculate the kinetic energy values. So what would be the initial kinetic energy value? We just calculate here. Ki initial, it would be equals to 1 divided by 2 half mv square. What is the mass of the projectile? It is 1.2. So 1 divided by 2 into m into v square. V is 5, 5 is square, plus 0, because for this trolley there is no initial velocity. So if we calculate this, this would turn out to be 15 joule. Okay, we call this as our equation 1. Now this result, let's say this is our second result. Now to calculate the final kinetic energy, we need to know what is the final velocity. Till we know the final velocity, we cannot calculate the this final kinetic energy. How to get the value? So in this situation, this trolley is free to move in the horizontal direction. So there is no net force in the horizontal direction. Okay, on this system, on the trolley projectile system, there would be a net force in the vertical direction. Okay, there would be external force in the vertical direction. Okay, due to the normal reaction, but there is no force in the horizontal direction. So we can say that momentum would be conserved in the horizontal direction. So this initial momentum in the x direction would be equals to final momentum in the x direction. So what is the initial momentum in the x direction? It would be mass of the projectile, which is 1.2, into velocity in the x direction. So this is making an angle of 5 with the horizontal. So what is this component? It would be 5 cos of 37. So the velocity in the horizontal direction would be equals to 5 into cos of 37. Now for the projectile, there is no velocity in the horizontal direction in the initial case. Now in the final case, since the collision is perfectly inelastic, so both the mass would be moving with the common velocity. So the momentum would be 1.2 plus this is the mass of the projectile plus mass of the trolley is 3.6 into the common velocity v. Okay, if we solve this, then our common velocity would turn out to be 1 meter per second. Now if this is the velocity, what is the final kinetic energy? It would be equals to 1 divided by 2 into m into v square. This projectile mass is 1.2 into 1 square plus 1 divided by 2 into trolley mass is 3.6 into the common velocity is 1 square. So this result would be equals to 2.4 joule. Okay, this is our third equation. So if you put values from this 3 and 2 into 1, we get the value of the heat. So heat would be basically the difference of the two quantities. So heat we denote as Q. This would be 15 initial kinetic energy minus final kinetic energy 2.4. So this result would turn out to be 12.6 joule. Okay, so 12.6 joule amount of this heat energy would be released from the collision. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.